Good morning students. In the previous class we see the formula of mean and variance. We continue the problem using the same concept of meaning and variance, but important to identify the given random variable false, either discrete or continuous is very important. You identify it is a discrete or continuous, then the problem is very easy. Now you see the next one. If nu and sigma square are the mean and variance, symbol is given, nu and sigma square are the mean and variance of the discrete random variable. They are given discrete random variable, and e of x plus 3 value is 10 and e of x plus 3 the whole square value is 116, then find mean and variance. So given in symbol nu and sigma square. Now to find these two values, given some data set there. First of all, e of x plus 3, that value is equal to 10. E of x plus 3 means the expectation of this x plus 3 is equal to 10. Now we multiply the expectation inside, we get e of x plus e of 3 is equal to 10. We already write the properties. E of x, any one of the constant lies within an expectation, the same number will lies. So e of 3 means the value is 3. Suppose e of 5 is the value is 5 is equal to 10. The plus 3 becomes that side minus 3. So e of x is equal to 10 minus 3. So e of x value is 7. This e of x is nothing but mean or average, or the symbol is nu. Therefore, mean or the symbol is nu or e of x. All are same. All value is 7. So to find the first one, mean is over. Next, to find the sigma square. The sigma square is variance. So also we use one more data. E of x plus 3 the whole square is 116. Now we use that value also. E of x plus 3 the whole square, that value is given 116. So E of, first of all, to expand this one using a plus b the whole square. The formula of a plus b the whole square is a square plus 2ab plus b square. So a square is x square plus 2ab. 2 of x of 3, 2 3s are 6, so 6 into x is 6x plus b square, the value of 3 square is 9 is equal to 116. Here also the outside e is common, so we multiply inside, we get e of x square plus e of 6x, e of 6x plus e of 9 is equal to 116. So all value we write. So e of x square plus, in expectation some constant and variable is lies, will be take outside the constant. So will be take outside the 6. Will be take outside the 6. The remaining is actually 6x is the, will be take outside 6. The remaining is 6 of ex plus, we already tell e of 9 value is 9 is equal to 116. So e of x square plus 6. We already find the value of e of x is nothing but mean. The value of mean is 7 plus 9 is equal to 116. So e of x square plus 6 hours are 42 plus 9 is equal to 116. So e of x square plus 42 plus 9 is 51 is equal to 116. So e of x square value is 116. The plus 51 becomes that side minus, so minus 51. So e of x square value is 6 minus 1 is a 5. 6 minus 1 is a 5. 11 minus 5 is 6. So to find e of x square also. Next, to find the variance. We already know the formula of variance. The symbol of variance is, just we say b of x or sigma square. The formula is e of x square minus e of x the whole square. So it is a formula of variance. Now to substitute the values. Expectation of x square, just we say e of x square. The value is 65 minus of e of x the whole square, that is the mean square. What is the value of the mean? The value of the mean, we already find that value is 7. So 65 minus the value of 7 square is 49. 65, 49. 15 minus 9 is 6. We take one borrow, so 60. So it is a value of v of x. But you see in the question the value is given in some symbol. Therefore, mean, whose symbol is a new, and that value is a 7. Next one is a variance, whose symbol is sigma square, that value is 16. So mean value is a 7 and the variance sigma square value is 16. Next we move to the next one. 4 fair coins are tossed once. See important, how many coins? There will be 4 coins are tossed once. Find the probability mass function, mean and variance. So to find 3 subdivisions, first of all to find a probability mass function, because it is a discrete. We tossed just 4 coins only. And also to find the mean and variance for the number of heads. So very important to find the mean and variance of a number of heads. So to find some probability value, so important to find the value of the sample phase. Because P of A formula is N of A by N of A. So N of S is very important. Here the value of N of S is, I say, 2 power 4. You identify why it is 2 power 4. When the coin are tossed, the general formula is 2 power n, where n indicates the number of coin. Here, how many coins are there? 4 coins. So 2 power 4. The value of 2 power 4 is 16. So n of s is here 16. Next, to find the probability means to find the random variable values. Let x denote the number of x when how many coins are tossed? 4 coins. When 4 coins are tossed, we identify x is the number of heads when 4 coins are tossed. Then this x is a random variable which can take the values the value of the random variables are very important, which can take the values. You identify 4 coins are tossed. We take x is the number of heads. Let x denote the number of heads. We tossed 4 coins at a time. I say one event is all the 4 coin is not yet. There is a chance. So the number of head is here 0. It's a 1 chance. We take another one. Out of 4 coins, any 1 coin is head and all the remaining 3 coins are tail. It's another chance. So whose random variable value is 1. Next 2, 3, 4. So x can take these 5 values. 0 means no head. 1 means out of 4 coin 1 head. 2, 3, 4. 4 means all the 4 coin having the face is 8. 5 will not come. Why? We tossed only 4 coins. So the maximum number of 8 will call 4. So the random variable values are 0, 1, 2, 3 and 4. So the first step to find the values of the random variable. The next step to find the probability of each and every random variable. The first random variable value is 0. So to find P of x is equal to 0. P of x is equal to 0. For understanding, I write first of all P of no head. P of means probability of getting no head. First of all, I write the sample base. Here, n of s. The value of n of s is 16. In numerator, we assume there is no head out of 4 coins. So using combinations, 4c 0. The value of 4c is 0. The variable is 1 by 16. So P of x is equal to 0 value is 1 by 16. Or we say it is f of 0. Next. P of x is equal to 1. P of x is equal to 1 means the number of 8 is 1 out of 4 coins. So we say 4c1 by n of s value is 16. The value of 4c1, 4 by 16. There is a chance to cancel here, 1 by 4. But to form a probability mass function, we add all, the final answer will come, we'll check. So I keep as it is 4 by 16. Next, P of x is equal to 2. 4c2 by 16. Why I write 4c2 here? Out of 4 coin, we assume there will be 2x. So 4c2 by 16. The value of 4c2, 4 into 3 by 1 into 2. There is a cancel in chances. So 2 3s are 6. Is 6 by 16. P of x is equal to 3. 4c3 by 16. Okay, 4c3 by 16. But you know the formula of NCR is equal to NC n minus r. So 4c3 is equal to 4c1 by 16. How we write 1 here? 4 minus 3 is 1. Again, the value of 4c1 is 4 by 16. Last, P of x is equal to 4. 4c4 by 16. Suppose both values are same, that value is 1 by 16. So, to find the probability of each and every random variable values. The next step is to form a table. The name of the table is the probability mass function. The probability mass function is. Now we form a table. The first row indicates the values of the random variable. And the next one is whose probability values. Just we write capital X, or capital X is equal to small letter x. Next, P of capital X is equal to small x. We write any one, or we say it is f of x. So in two symbol we use any one of them. What is the total number of the random variable values? There will be 5 values from 0 to 4. So 0, 1, 2, 3 and 4. 0, 1, 2, 3, 4. When x is 0, whose probability value is? When x is 0, whose probability value is? 1 by 16. When x is 1, whose probability value is? 4 by 16. When x is 2, whose probability value is? 6 by 16. When x is 3, whose probability value is 4 by 16. When x is 4, whose probability value is 1 by 16. Now we see, we find all probability value. We know very well the total probability value is always is equal to 1. You check the addition of all, it should come 1, our answer is correct. You see all the denominators are 16. Here are the numerators. 1 plus 4, 5. 5 plus 6, 11 is 12 and 16. So 16 by 16 is 1. So our answer is correct. So it is the first submission is that is to find the probability mass function. But so 2 more questions is also there in the same question. Next also to find the mean and variance. Now to find the mean. The symbol of mean is E of x. What is the formula we used here? There will be 2 formula of mean. Either it falls in discrete or continuous. You see it falls in discrete or continuous? It falls in discrete because a finite number of elements is there. It is a countable. Therefore it is a discrete. When x is discrete, E of x formula is a summation of x into f of x. So the first value of x is summation of x into f of x. The first value of x is 0. Whose probability value? F of x means, you see, whose probability value? That is f of 0. The value is 1 by 16. Plus summation plus. The next value of x is 1. And f of x means whose probability value is 4 by 16. Plus. Next value of f of x is 2. Whose probability value is 6 by 16. Next value is 3, whose probability value is 4 by 16. Plus 4, whose probability value is 1 by 16. The simplification is your choice, we simplify anywhere. But for our easy simplification, I will take outside the 16 in each and every term in denominator. You see, the denominator is common in each and every term. The first term is actually vanished. 0 to anything is always 0. Next, in all the term, I will take outside first of all 1 by 16. I will take outside 1 by 16. What is the remaining first term? Actually, I will take outside 1 by 16. 1 into 4, sir, 4. Plus, we take outside the 16. So 2 into 6. 2 6 are 12. Plus, 3 4 sir, 12. Plus, 4 1 sir, 4. So outside is a 1 by 16. And we add all the value, we get 4 plus 12 is a 16. 20 and 32. So 32, we cancel, we get 2. Therefore, E of x value is equal to 2. Where E of x is nothing but mean. So the value of mean is equal to 2. Next we find variance. But the formula of variance is E of x square minus E of x the whole square. We already find the value of E of x only. In variance, the first step is we need E of x square. So first we write the formula of E of x square. The formula is summation of x square into f of x. What is the reason to use this formula? Because this x follows the discrete random variable. Summation of the product of the random variable square whose probability value. So summation of x square into f of x. The probability value and whose random variable value is square. E of x square. The first random variable value is 0. The first random variable value is, you see the table, the first random variable value is 0. So whose square into whose probability value, that value is 1 by 16. So you do the work as it is. Plus the second random variable value is 1. So 1 square whose probability value, plus 2 square whose probability value. So we write up to add or 4. So first 0 square into 1 by 16 plus the next random variable value is 1 whose square. So 1 square divide by into whose probability value is 4 by 16 plus the next random variable value is 2 whose square is 2 square into whose probability value. The value of the probability value is 6 by 16 plus the next random variable value is 3. So whose square into whose probability value is 4 by 16 plus the last random variable value is 4 whose square into whose probability value is 1 by 16. Actually this one is cancelled because 0 and anything is always 0. The next is simplification. The value of 1 square is 1 into 4 by 16 plus the value of 2 square 4 into 6 by 16 plus the value of 3 square 9 into 4 by 16 plus the value of 4 square is 16 into 1 by 16. The simplification is your choice, we cancel anywhere. But for our easy simplification, I will take here also 1 by 16 outside. In all the term, denominator 16 is common. I will take outside. What is the remaining first term? 1 4 4. Second term, 4 6 24. 9 4 36 and 160 is 16. So simplification is easy one. So I will take outside the common 1 by 16. Now we add the terms. 4 plus 24 is 28. Okay, 28. 36 and 16 is 8 plus 4 is 8 plus 6 is 14 and 20 is 0, remaining is 2, 4, 5 is 8. So actually 80. So addition is your choice, you add anywhere. So the sum of all the term value is 80. Actually 80 by 16. 1 by 16 of 80 or 80 by 16. In direct cancel of a 16th table, E of x square is exactly 5. 5 16s are 80. Now we write the value or the formula of the variance. V of x is equal to E of x square minus E of x the whole square. Expectation of x square, E of x square is 5 minus, we already find the value of the mean. The value of the mean is 2 square. So 5 minus 4 is 1. So V of x value is 1. So So in result, the value of mean is equal to 2 and the value of the variance is 1. So we find 3 values. First we find the probability mass function to form a table. Next, to find the value of the mean and variance. The sum is very easy, but we identify the given random variable x follows. It may be in a discrete or continuous. The problem is involving in a discrete, so using summation. Suppose the same problem is a random variable x suppose falls in a continuous, using the concept of integration. We move the next one. Actually the question is very big, but the answer is very short. The concept of the question is a commuter train arrives punctually at a station every half an hour. So a train will come every half an hour, punctually will come. Every day in the morning, a student leaves his home to the railway station. Every day morning. Let x denote the amount of time. Here x denote the amount of time in minutes that the station waits for the train from that time he reaches the railway station. Okay. Then the PDF of f is, we already say what is my PDF? Probability density function. So the student is wait. So the train will come actually the punctually time. In some more time it will come some late. So to find the late, that is to find the reaches the railway station, the PDF of f is, so f of x is equal to 1 by 30 when x is lies between in this interval 0 to 30. 0 is elsewhere. Elsewhere means suppose the value of x is some negative value or more than 30, f of x value is 0. Our question is obtain and interpret the expected value of the random variable x. So expected value. The expected value symbol is e of x. So to find e of x here, that is to find mean value, but f of x falls in PDF. So directly we write the answer. We know that e of x is nothing but expectation of x. It falls in PDF, so the formula is minus infinity to plus infinity x into f of x, because it falls in the probability density function, so continuous random variable. So minus infinity to plus infinity x into f of x dx. But f of x is possible only when in this interval 0 to 30. So how to change the given limits minus infinity to plus infinity? How to change the given integral become 0 to 30 x into f of x dx. Why I write 0 to 30 here? In this interval only f of x is possible. Sir, actually 0 less than x less than 30, so how to come 0? We already tell in a continuous random variable 0 is less than is nothing but less than or is equal. X value it may be 0 also possible. Less than 30 means the value of x it may be 30 is also possible. So 0 to 30 x into f of x dx. 0 to 30 x. In this interval, how to define f of x? The value of f of x is defined as 1 by 30 into dx. So if we take outside 1 by 30, 0 to 1 by 30 will be take outside 0 to 30 x into dx. So that's value is power. Will be take outside the constant. So x into dx. 1 by 30. The integrating of x is x square by 2 and the limits are 0 to 30. First we will be take outside the constant. 30 into 2 is 60. So 1 by 60. X square of 0 to 30. 1 by 60. We substitute the limit. The upper limit is 30. So 30 square. Minus lower limit is 0. So 0 square. The value is vanish. So 1 by 30. The value of 1 by 60 of 30 square. The value of 30 square is 900. 1 0 is cancelled. 90 by 6. Directly we cancel in the sixth table. So E of x value is 15. It's just 15 minutes. So in a particular day, the train will arrive 15 minutes delay. So average time of delay is 15 minutes. So expected value is equal to 15 minutes. We stop here. Or the average delay is enough. The expected value is 15 minutes. Or the average delay is 15 minutes. E of x means average. So we write in any one, expected value is 15 minutes or the average delay on a particular day is 15 minutes. Next we move the sixth one. The time to failure in thousands hours of an electronic equipment used in a manufactured computer has the density function. Now important, the given problem following a density. A density means it falls in a continuous random variable. So failure in 1,000 hours. That is, one computer is manufactured whose average working hour is 1,000 hours. But all the computer is not come in 1,000 hours working. Some more computer will come in less than hour also. So whose function value is given 3 into e power minus 3x when x is greater than 0. That is, when x is a positive value, f of x is some value. 0 is elsewhere. That means when x is a negative value, f of x value is 0. It is given a function value, the time to failure. Actually, the given one is a time to failure. Then our question is find the expected life of these electronic equipments. So failure statement is given to find the expected life statement. So first we find the expectation of the failure. Actually, it's a given. It's the expectation of the failure is a chances. It falls in a density function. Therefore, using the concept of the continuous random variable. First, we write this formula. E of x minus infinity to plus infinity x into f of x dx. Why I use the formula here? X follows the continuous random variable. So x into f of x dx. But our f of x is possible only when the value of x is more than 0, is greater than 0. So minus infinity to plus infinity, how to change? Minus infinity to 0, in this interval our f of x value is 0. From 0 to infinity, f of x value is 3 into e power minus 3x. So 0 to infinity x. So in this interval, f of x value is defined as, you see, 3 e power minus 3x into dx. Now we integrate that term. Here that 3 is a constant, we will take outside 3. So 0 to infinity x into e power minus 3x dx. We know very well what is the value of this integration. You see the term, we already see in so many classes. Now it is of the form 0 to infinity x power m e power minus ax into dx. Same form. The formula of this integration is n factorial divided by a power n plus 1. We compare the formula to our given sum. In place of n here, no 1, so 1 is understood. And in place of a here, 3. So here, the value of n is 1 and the value of a is equal to 3. Now we use the value in the given problem. But outside the number 3 is very important. So first we write the number 3. The formula is n factorial. The value of n is here, 1. So 1 factorial by a power n plus 1. The value of a is 3. Power. The value of n is 1. 1 plus 1. 3 of. The value of 1 factorial is 1 by 3 square. So 1 3 is cancelled. So e of x is equal to 1 by 3. Therefore, this is called expected failure. 1 by 3 into 1000. E of x value. So expected failure is 1 by 3 into 1000. Why I write 1000 here? In a given sum, you see, in a given sum, failure is in 1000 hours of an electronic equipment. In out of 1000 hours, the failure statement is given. Therefore, the expected failure is 1 by 3 into 1000. We expected. But our question is to find the expected life. It's not a failure. The expected life. Therefore, the expected life, it is the chances of the failure. Expected means chances of the failure. So what is the chances of the success? Life is nothing but success. So failure probability is 1 by 3 into 1000. So the success probability is a 1 by 3, whose reverse is 2 by 3. Important, in the previous one we find E of x, the answer is over. But it's a special sum. The given one is the expectation of the failure. But our question is, what is the expectation of the success? Success is nothing but expectation of the life. That is expected life of the computer. So expected life is equal to 2 by 3 into 1000. Why I write 2 by 3 here? The expectation of the failure is 1 by 3. So failure chances is 1 by 3. So what is the success chances? It's a 2 by 3 because the total probability is 1. Either success or failure. Both are had, we get 1. So 1 by 3 is there. So success probability is a 2 by 3. But the average hour is 1000. So I write here 1000. Actually 2 into 1000 is 2000 by 3. The process is going on. 6, 6, 6. 6 times 18. Remainder 2. Again 6 times. Again 6 times. Point. Again 20 is 6, 6, 6. The process is going on. So expected life is approximately, we write 666 point. The process is going on. We stop anywhere. I stop 6.67 hours. Where expected life of a computer will be take 666.67 hours. Actually, the computer manufacturer hour is maximum 1000 hours. But all the computer will not come in 1000 hours. So suppose we want to buy one computer, we expect the average working hour is 666.6 hours. It may be it works more than hour of that one, or less than the hour of this one also. But the expected is nothing but we expect the electronic item, it will be working average of 666.67 hours. Okay students, now we see some problem involving mean and variance. The same model sum lies in example also. You just see the question of the example, then we close all the material, we write each and every problems.